This one-point lesson is designed to help you understand the UPH metric in the VCF and how to upgrade the UPH using your Engineering Action Planner tool. Towards that objective, this OPL will cover four main topics: the definition of UPH and UPH bottleneck, the definition of entitled UPH and UPH loss, predicting how your engineering effort will improve the UPH, and uploading your plan into the VCF using the Engineering Action Planner tool. UPH is a tool metric that describes the throughput of a given production tool. It stands for units per hour. It's the number of units that are processed in 1 hour. The definition of UPH is the number of units that are in a lot divided by the amount of time that it takes to process that lot. You can see the UPH of all of your tools simply by mousing over its tool icon in the VMES. So for example here, the rear to print dry fire step has a UPH of 120 units per hour. Another expression of throughput is the lot process time. That's just given by the number of lots that are in a unit divided by the UPH. Another important concept is the UPH bottleneck. This is the production step that limits the overall productivity of your line. This table shows the UPH values for each of the production steps in the VCF. Here's the UPH. And the calculated process time for each of those steps, ranging from 40 minutes all the way up to 63 minutes. The bottleneck step is the arc process step, at 63 minutes process time per lot. It also has the lowest UPH. So if we make a plot of each step and show the process time, we can see that the UPH bottleneck here is the anti reflection coating step at 63 minutes. This is the step that will limit the overall productivity of your line. It's important to keep in mind the step yield when using the lot processing time to examine the UPH bottleneck. This is because yield losses at each step will lower the number of units in any given lot, and therefore will reduce the amount of time required for processing. When we reanalyze the bottleneck, taking into account step yields, it creates a slightly different picture. Now the depth diff process is the UPH bottleneck with a process time of 56 minutes per lot, as shown here in this graph. The entitled UPH is the theoretical best UPH that a production tool can achieve. Every tool in a production line has a different entitled UPH. In the VCF, the entitled UPH is 180 units per hour. The UPS loss, then, is the difference between the entitled UPH and the actual UPH of the tool. For example, if we look at the arc process step, it has an entitled UPH of 180 units per hour, an actual UPH of 100 units per hour, and therefore it has a UPH loss of 80 units per hour. Why would the UPH be lower than the entitled UPH? Well, this can be for any number of reasons. For example, it takes too long to set up the tool. So every production shift change, or every time we change a screen, or every time we want to recalibrate a tool, it takes a little bit of time for the operators to set up the tool. And sometimes this takes too long, depending on the nature of the tool and the skill of the operators. Sometimes the operators are slow to load or unload the tool, resulting in a slow operation of the tool. Sometimes there are internal tool errors or alarms that stop the tool and require operator attention in order to continue. There are unscheduled faults that might require engineering repair or maintenance. There are mechanical components that are not well synchronized. Sometimes the unit density is lower than desired inside the tool. And sometimes the process recipe itself lowers the throughput. For example, in a text etch process, the UPH loss is 0, and the throughput of the tool is entirely limited by etch and rinse speed. You can use your engineering hours in order to reduce UPH loss. Here's the formula that predicts the new UPH loss as a function of the amount of effort that you apply to fixing UPH loss. The predicted UPH loss will be the current UPH loss divided by 1.03 to the power of n, where n is the number of hours that you devote to reducing UPH loss. And the new UPH of the tool will be the entitled UPH, which doesn't change, minus the predicted UPH loss, which will change depending on the amount of effort you apply to lowering UPH loss. Here's how you can improve your UPH in the VMES. Use the Engineering Action Planner tool in order to create an action plan. First, click on the Throughput tab, and then right-click here in the small box and select Add New Activity. In the New Activity row, select the step that you would like to work on, and then select the number of hours that you would like to execute. When you're finished, click the OK button in order to upload your new plan to the VCF. Okay, a few key takeaways. The UPH is a measure of tool throughput. Compute the lot process times in order to determine the UPH bottleneck step. Remember, the bottleneck step limits the overall line productivity. The longest lot process time is the UPH bottleneck step. And be sure to account for the upstream step yields when looking at your UPH bottleneck step. The UPH loss is the entitled UPH minus the actual UPH. Engineering effort will reduce your UPH loss. Here's an important note. The UPH loss for the text etch step in the VCF is 0. So any engineering effort you spend will have no effect. Finally, use the Engineering Action Planner menu in the VMES to implement your plan in the VCF. If you have any questions or comments about this OPL, please contact me at the following email address.